Hello, my name is Rhodesha, and this is my interview practice.
1. What does the CRISP-DM methodology for data mining entail? CRISP-DM is a six-step process used to guide data mining projects. It starts with business understanding, where the analyst defines the problem and success criteria from a business perspective. In data understanding, they gather and explore the data to identify patterns or issues. Next is data preparation, where data is cleaned, transformed, and structured. This is often the most time-consuming step. Then comes modeling, where statistical or machine learning techniques are applied to the prepared data. Analysts test different models and tune parameters for the best results. In the evaluation phase, they check if the model meets the business goals using metrics and visual validation. Finally, in deployment, the results are shared with stakeholders, or the model is integrated into a system. This process is iterative. Analysts may revisit earlier steps as new insights emerge. 2. What does time series analysis involve before forecasting? Before forecasting a time series, analysts need to understand the structure of the data over time. First, they visualize the data to spot trends, seasonality, and anomalies. Next, they check for stationarity, whether the data's mean and variance stay constant. Many models require stationary data, so transformations like differencing or logarithms may be used. Decomposition is also important, breaking the series into trend, seasonality, and residuals. Analysts use tools like ACF and PACF plots to find log relationships and identify model parameters. Removing outliers or smoothing the data helps improve accuracy. Overall, time series analysis prepares the data so the forecast model can make reliable predictions based on historical patterns. 3. What are the main principles of data ethics, and how can companies uphold them? The key principles of data ethics include privacy, transparency, fairness, accountability, and security. Privacy ensures that individuals control their own data. Transparency means being honest about how data is collected and used. Fairness involves preventing bias or discrimination in data and models. Accountability ensures companies take responsibility for their data practices, and security protects data from breaches or misuse. To uphold these values, companies can audit data systems regularly, use diverse datasets, anonymize sensitive data, and implement explainable models. They should also train staff on ethical practices and provide clear data policies to users. These steps help build trust and reduce the risks associated with data misuse. 4. How would you raise concerns about bias in a predictive model and avoid it in the future? If I notice bias in a model, I'd bring it to my manager with evidence and a solutions focused tone. I might say, I found that our model performs differently across demographic groups. Can we take a closer look at the training data and evaluation method? Using charts or metrics to support the concern helps the conversation stay objective. To avoid bias long term, we should ensure our training data represents all user groups and check for fairness metrics, like demographic parity. Evaluating model performance across subgroups and involving diverse perspectives in model review also helps. These steps promote equity and ensure the model works fairly for everyone it impacts. 5. What's the difference between regression and classification models, and when should you use each? Regression and classification are both predictive modeling techniques, but they serve different purposes. Regression models predict continuous values, like income, price, or temperature. You'd use regression when your target variable is a number, and common models include linear regression or REMA for time-based data. Classification models, on the other hand, predict categories or labels, like whether an email is spam or a transaction is fraudulent. Use classification when the outcome is a fixed group, like yes or no. Logistic regression, decision trees, and random forest are typical classification models. In short, use regression for numeric predictions and classification when sorting data into distinct categories.